Let's take a look at materials commonly used in prototyping and rapid production. I'll define the main material types of polymers, thermoplastics, and elastomers with example materials, key features, and differences. Lastly, I'll talk about some of the different forms these materials can come in, as that affects which processes they can be used in. For better or for worse, there's a ton of crossover between categories due to the shared nature of formable materials, so there are crossover exceptions in almost every category. As you can see, polymers divided first into thermoplastic and thermosetting categories, which do not intersect. And elastomers are generally thermoset, but some are thermoplastic. This will make more sense in a minute. I promise I'll only talk about the molecular chemistry of materials for this first differentiation. The rest is qualitative comparison. Polymers are the overall main category of materials that exhibit plastic or formable characteristics. It's their unique structure that makes them special. Polymers consist of extremely long molecular chains that are represented with overlapping atom loops and are the basis for the rest of the materials described in this chapter. Thermoplastics are a category of polymer that can be heated and reformed multiple times. They have high plasticity in their ability to melt, flow, bend, and repeat. Remember our ice cube example? ABS is a common synthetic thermoplastic used for consumer goods and automotive parts, which exhibits high impact resistance and durability. Thermosets are the other main category of polymers, which have extra toughness due to the fact that they go through a chemical reaction called cross-linking, where it cures until its final structure. The change creates strong bonds that don't melt. Remember our egg example? They're usually very heat resistant, though at a certain limit they start to degrade instead of melting. Melamine and polyester resins are common thermosets used for sheet applications like counter surfaces. They hold up for a very long time. Elastomers are polymers that have both formable plastic characteristics and elastic or squishy characteristics, which means that when force is applied, they can stretch or compress, and when force is released, they can spring back into shape. Elastomers include materials like silicone, natural gum tree rubber, and some foams. Now that the categories have been established, it's time to talk about the different forms these materials can come in. With thermoset materials, the isolated components are often kept in a liquid form until they are needed for combination and molding. With thermoplastic materials, the plastic is melted with heat in preparation for extrusion or injection molding. Pellets are one of the most common forms of thermoplastics prior to injection or extrusion. Pellets are useful because they're reasonably easy to measure and because their high surface area helps them melt quickly and completely for pressurized injection. Powders are finely ground plastics, generally thermoplastics, used in hot mold melting processes like rotational molding. Because powders have an extremely high surface area, this enables them to melt extremely quickly and flow into all of the surface details of the mold. Extrusions are also generally thermoplastics that have been melted and pushed out of a machine in a solid cross-section. One of the common extrusions you might have already run into are filaments. Filaments are extrusions with round profiles used in 3D printing, kept solid on spools until heated for re-extrusion to 3D print your part. Putty charges are commonly thermoset materials placed in heated molds for thermoforming. The material is already in a semi-solid clay-like consistency. Other materials in this category would include both naturally occurring and synthetic clay and waxes used to create master forms. Some car companies still use clay sculpting techniques to help define their designs. Foams are special because of the way that they're made. Air is introduced either by mixing components that create a chemical reaction or by being frothed up mechanically with an inert gas to encourage bubble formation. Foams can be made from either thermoset or thermoplastic materials to create strong and rigid foams or soft and pliable ones. An interesting thermoset elastomer foam is polyurethane foam, which combines highly squishy pliability with high toughness. This addition of air creates a great application for flotation devices, impact, and sound insulation due to its low density. While this definitely helps overview the different categories and forms materials can come in, you'll have to do some exploring on your own to find the best materials for your project. Different projects have different needs, so first establish what you need and want your part to do, and then research the best material to fit those needs.